By the way, because my job is to finish by chapter number 10, so the key chapters are the chapters by chapter number 6. So before 6 are the key chapters. So we need to pay close attention to from 7 to 10. We give a very quick look of the key concept. Right? This is the method we're going to do this. This is how we're going to do the different chapters today. And for back to LAN fundamentals, because just now we already know the OSM model. So then we gonna go to see the knowledge or see the protocol one layer by another. Right now we come to LAN fundamental. So here talking about LAN, we come to the data link layer and the physical layer. Right. So this again, right now we are doing the new knowledge learning based on OSI reference model. So this is the thing I mentioned just now. We will keep a look back time to time, right? For this one, LAN technology belongs to layer 2 and layer 1 of OSI model. LAN overview. Let's take a look. LAN protocol covers the range from physical to network layer, and mostly is between this data link layer and the physical layer. And physical layer is talking about what kind of cable you're using, right? And the data link layer is an Ethernet or is a token ring or something else. This is the data link layer. For network layer, actually, it's not the LAN's job. It's a network layer's job, right? So basically, it's a LAN protocol covers the data link layer and the physical layer. And this is a typical topology or typical technology which has been existing from the beginning, maybe from the earlier stage of the IP technology. Nowadays, the most popular one, or most common seen one, is the Ethernet, right? No matter it's your in the enterprises, your company, in the hospital, the most core area of network still use this Ethernet type of network. So it's still common use or popular use because of the feature of high speed of transmission, right? High speed of transmission. So this is the Ethernet type. And for token ring and FDDI ring, so these two these technologies exist for some time in ISP network, in the service provider, internet service providers network, or in some big company or big, let's say, big enterprises. Even inside the big enterprises, for example, they have a different plant or different headquarters crossing the country. So they also use FDDI rings, but mostly in service provider, like internet service provider. But these two already, I think it's in the books. And for Ethernet technology, we're talking about is the most popular using one, and also have a very long history to develop itself. For the earlier ages, we could say this is the earlier ages technology of Ethernet, and this. Oh, sorry, I used the pointer. And this on this page we could see the name and the speed and the media. So the key point is not to remember all the name. The key point is how to know the naming system. So the first 2 digits or first 3 digits, 4 digits, the first one, the digits means the bandwidth, right? Base is the common one, and the last digits indicates no matter is the distance, right? In earlier ages, distance, and nowadays is the media. It means the media. So also they have their own meanings in the naming system. So the key point is to getting to know when when the exam give you one name, so you need to know what is the bandwidth it is and what is the medium it is, right? For 5.2 is the distance, but right now it's not using. Right now the last digits means the medium that this technology using, right? And bus type or by using the hub, right? This is another key point. And Ethernet hub come out into the commercial use during that stage. It's also the early stage of Ethernet developing. So for a hub, if you have the touch with the internet on an earlier age, you all may see this hub or repeater, this kind of devices, devices in the earlier stage. And I used to have one. And in the hub is a bus line, is a bus type network in the hub. And the key point for hub is Ethernet hub is a device which works on physical layer only. So this is the key information for a hub, like on this map, on this picture, 4 hosts connected to one hub, and inside the hub is a bus line, and the hub, the key information, work at only physical layer. The meaning is hub only transmit the bit stream that sent out from every host directly. Hub do not proceed any information from layer 2. No, layer 2, layer 3, layer 4. No, hub do not deal with any information from layer 2. It just transparently transmit the bit stream transparently on the bus line. So this is what hub means. And remember, I repeat, is a physical layer device, right? This is what hub means. And MDI-X, so this information is totally, actually is totally unnecessary for our daily work, but it's necessary for our A3C exam because it's a knowledge point. So at an earlier stage, every network device interface are divided into 2 kinds due to their ports type. They are divided into MDI and MDI-X. They belong to different type of media, and to this different media, in order to make the communication possible between these 2 kind of devices, engineers need to choose the correct cable to connect the different devices to make them commute, to make them work. So on this map shows you the correct cable you need to choose between different kind of media, between MDI or MDI-X. But the good thing is we don't have to remember all this map, all the information. You just need to remember one sentence listed below, right? For straight through cables for the interface of different types, and crossover cables for the same type of interface. So this here, different type at the same time means the MDI, MDI-X, right? For example, if your host used the NIC MDI and the opposite side also use the NIC of MDI, then you need to choose the crossover type of Ethernet cable. On the contrary, if this one MDI-X connects with the MDI, you need to choose the straight through kind of cable, right? Straight through cable. So this is the sentence. So in order to remember this in the short way, in a simpler way, to just remember is the same cross. You can say, remember this, same cross and different straight. Just a 4 word. Same cross, different straight. So this sentence or this 4 words represent this table perfectly, right? Just remember this. You choose the correct answer on your A3C NE exam. So this is the information you need for exam. But in the daily use, all the switches, all the product of all vendors already support auto MDR, MDX. So that means no matter what kind of cable you choose, as long as the cable works, as long as the cable is good, the communication will be good. So you don't have to worry about the type of Ethernet cable anymore. So for the real case is the auto MDR, MDX. Right. So this is for this part. And because on this page we mentioned about the straight-through cable and crossover cable, we need to take a look at what is the straight-through and the crossover, right? So this is our RJ45 connector, the cables, the Ethernet cable, aka Ethernet cable. So for the straight-through cable, that means we can see at this this will be called a crystal connector. On this connector, there are 8 pins on the cable, and also the 8 pins connected with the twisted pair of lines inside the cable. Right, these are 8 pins. You can see these are 8 lines, and if the cable, the pin actually, we can see this cable have two sides, right? The one cable, 2 RJ45 connectors on the left side and the right side. You can see if the pin's direction, the sequence of pin is laid like this, it's actually directly connected with each other with no cross. So this is what we call the straight-through cable. And for crossover, that means the sequence has been changed by the connection between the 2 RJ45. So this is called a crossover. But here the key information is for crossover, it's not crossover randomly. They crossover the pair with certain rule. So the rule is the one we need to prepare. We need to remember for the exam. Is just remember it's the 1, 2, 3 fix. 1, 2, 3, 6. 1 with 3. 1, 2, 3, 6. Right. 1 with 3. 1 with 3. 2 with 6. 2 with 6. So this is a 1, 2, 3, 6. Crossed over. But for 4, 5, 7, 8 are still straight. So this is the key knowledge we need to remember, right? For straight through, they connect with each other, 2 sides connected with each other straightly. But for crossover, 1, 2, 3 fix are crossovered, right? So this is the information we need to remember from exam. Okay, so back to the knowledge point of the physical layer, because just now we already acquired the knowledge that a hub is a physical layer devices, and the hub only transmit the speed stream transparently on the line, right? So let's just say this part is a hub. It's a bus type of network, and 3 hosts connected together, and the hub only transfer or transmit the bit stream, right? So under this circumstance, we could see they will have collision, physical collision sometime, right? If they sending the bit stream together, they will have the collision. So that's why the CSMA CD technology come to develop. This technology is being used to detect collision and to solve the collision after detecting it. So this is called CSMA CD, right? And CD represents for collision detection. And why I mention this, because on Wi-Fi technology, it also have a CSMA tech. It's called CSMA-CA. It's called collision avoidance. The method they deal with collision is a little bit different. So here we take a look at CMSA CD at first, right? Back to the topology, 3 host, bus line, we say this is a hub. So when some host is sending the bit stream, so the carrier, right? The carrier is being sensed by the line is occupied. So the carrier is sensed by all the host. So when they sense the carrier, all the hosts will suppress their transmission, suppress their bit transmission, right? On this map, on this picture, host on the left sending the bit stream right now. So carrier sensed, the host on the right side do not send any bit stream, right? So after the bit stream is finished, is done transmitting, the line is idle, became idle, and no carrier is sensed by any of these 3 hosts. So all the hosts understand, oh, this line is idle and could be used. And they, after sense no carrier, all the hosts will send the bit stream immediately. Or they can send, they are able to send their information, send the bit stream immediately, as long as their uplink layer asks, right? As long as there is a encapsulated information down to this physical layer, they can send the bit stream immediately. So this is what the host do when no carrier is sensed, and the data will be sent. For example, this host on the top right sends no carrier, and he start a new bit stream, and the bit stream will send to a host on the left and a host on the bottom right, and this is the normal situation when there's no collision, right? But imagine when the line is idle and both host on the left and the host on the top right want to send something at the same time. So here, like this, sending. So there is a collision. There's a collision detect, right? So the CSMA CD will work. So the CSMA CD will compel all the hosts to back off for a random time. So we call it random back off time. So they will shut up for random time, and no one send the bit stream during this time. And after the random back off time is running up, the host with the shortest back off time will start to send the bit stream again. So this is how CSMA CD work, right? Because it's detect the collision at first and work to back off the transmission then. So we call it CD, collision detection, right? For CA is different. So we will teach that part later, right? And another thing for LAN technology, because we said it's a LAN belongs to layer 1 and layer 2. So we finished layer 1, physical layers information just now, right? CSMA CD, also the hub. And now we came to MAC address. It's a layer 2 information. It's a layer 2 technology. It's called MAC address. So let's take an example for this PC. The PC actually have a 2 kind of address. One is IP address, which is assigned by network layer. So this address is a logical address, and this address is the pattern is dotted decimal. So this IP address will be recorded or restored in RAM. For example, in the SD-RAM, right? It's running in operating system. It's a logical address, and the engineer could change this address as much as they can, as much as they want, right? Because it's in RAM, it could be reconfigured by engineer anytime. It's a logical address. But for the PC, it also have a address physically exists in the NIC card. So this card is fixed, stored in the ROM, and when this device is manufactured and put into the market, so the device's market address is fixed already. So it's stored in the ROM and cannot be changed very easily. It cannot be changed, right? This is the difference between market address and IP address. One more time. IP address is a logical address. It's existing in RAM and could be changed, could be reconfigured by engineer anytime. Market address is a physical address, or it's a data link layer address. It exists in the ROM and cannot be changed freely. Right? This is the difference. Different layer have different addressing, right? And compared against the IP address, the pattern of IP address is dotted hexamer. For market address is the market address is 48 bits. Sorry, let's take it. Let's explain this. Let's explain this again. For IP address, it's a dotted decimal after transmitted into the pattern that we are easy to understand. But for the original address of IP address, original pattern of IP address is a 32 binary. Is a 32 binary address. 32 bits address for this logical IP address. It's 32 bits. And after changing to the pattern that easy to remember, we used dotted hexamer to display the IP address. For market address, it's a 48 bits address, right? And after translated to the pattern that were easy to understand, is a 12 digits hexadecimal number. So the pattern is different, right? So this also will show up in your exam. So please remember the information. Okay, after knowing what is the MAC address, so we need to know that the MAC address, both MAC address and IP address exist in pair. So when I say pair, that means because this address is used for communication. So communication all have a source and destination, right? For example, we are doing the teaching right now. So source is me. I'm saying everything to you. I'm sending everything to you. So I'm the source and you're the destination, right? We have a destination. We have a receiver. So for the communication is the same. No matter IP or MAC, they all have the source and the destination. And if we take a look at the market address only, so we could say the market address in charge of the transmission on data link layer, or network interface layer on TCP/IP. And due to the different type of receiver, due to the different numbers of receiver, we could divide the communication into unicast and broadcast. Let's take a look at an example. In the picture on the top, we could see that the host on the left send out a frame logically, send out a frame on the line, right? Physically is a bit string. I emphasize this several times. Physically is a bit string, but logically send out the frame, right? With the destination mark. D mark means destination mark with this mark, right? And there are two hosts on the right side are waiting. And one with one market address is a 2222, and another one is 3333. When the frame reach the host on the right, so they will judge if the destination is me or not. For example, the bottom right host judge the destination mark is 2222. It's different with mine, so he will drop the frame. and for the one on the top right will receive this frame, right? Will accept this frame. So this kind of transmission, or this kind of communication, we call it unicast, because they only have the specific one receiver, right? For broadcast, the destination mark, it will be full F, right? This is a hexadecimal. The destination mark, when it's a full F, that means it's a broadcast mask. And no matter the host, no matter host on the physical segment, no matter their MAC address is, they will all accept this frame because the destination is pointing to a broadcast mask address. So here, knowledge point. On layer two, broadcast MAC address is full F, in hexadecimal number, right? So here we know what is the unicast, what is the broadcast, right? Then we come to the flow control function on layer two. Actually, there are two kind of flow control function. Sorry, my bad. I explained this in the wrong wording. So this is the Ethernet flow control. Have two methods. One is on physical layer. One is on Ethernet layer, on data link layer. You could say it like this. First type is a back pressure method. So this method is used for half duplex. And because we are also mentioned that on physical layer, there's a protocol called CSMA CD. So when they detect the collision, they will back off, right? So back pressure method flow control is using the CSMA method to create flow control window, right? For example, when this sender sending the information too quick, sending the bit stream too quick, and the host, who's the sender? No matter which one is sender. For example, the piece, the switch is the sender, PC is the receiver. And if the sender is sending this bit stream too quickly, so the host will generate a bit stream on the line on the opposite direction, right? On purpose. So they will generate this bit stream on purpose on the opposite direction. And physically, the CMSA CD will work, and they will all back off for some time, right? For random time. And the line will become idle, the flow will be controlled, right? This is the first method, back press. And the second method is to using the Ethernet frame. It's the special Ethernet frame with the special address. So if you learn S3C SE, they will call the SE will tell you that this address is actually it's a multicast market address. But no matter for S3C it's a special address. This address means a pulse frame. So this when user using the full duplex, they can send with each other with no collision. So this time, when the sender sending the information too quick, sending the frame too quick, the receiver could generate this frame with this MAC address, with this destination MAC address. So the opposite side, the sender will recognize this is a pulse frame. Is a pulse frame, and to stop sending the frame for a certain time. So this is the second way to pulse. So this is the two ways to do flow control in Ethernet protocol. Actually, one on physical layer, one on data link layer. Right. About the DMARC address, we need to remember. We need to memorize. Okay, I think the information on this page is mentioned about another hardware media is called repeater. A repeater is just similar with a physical hub. It's also a device worked on physical layer. Please remember this. No matter repeater or hub, they are both the devices working on physical layer, right? They cannot. They just they just expand the range of a physical network, of the physical layer of network. They just expand the range, but they cannot deal with the physical collision. This is the repeater and the hub do. And no matter how many ports repeater has, no matter how many ports a hub has, and the same with repeater, all the hosts connected by repeater or hub exist in same collision domain, right? The CSMA CD will work on this domain, right? Right? This sentence is important, right? Repeater and hub will not separate collision domain, right? This page is the same, right? All the devices in the network is a hub, so they all work at physical layer. They all deal with the bit stream information. So all the hosts under this network, under this physical segment, is in the same collision domain, and same as repeater, right? Same collision domain. So before. Oh, sorry. Okay, let's keep move on. So talking about the Ethernet nowadays, the technology have a very fierce development or fierce growth. We have, except the Ethernet cable, we already have different kind of fiber. On this page is talking about two kind of fibers: a single mode and a multi-mode. The key point is to remember the name and feature. For multi-mode, which means it could accept the light waves from different angles and to travel through the cable through different paths, different angle, different paths. So you can just imagine the light, when light goes through the fiber, they can go into the fiber with different angles, transmitted in the fiber by different paths. So this kind of fiber have a disadvantages to transmit with very limited distance. So they are shorter, but the cost is low. This is their feature. So this we need to remember, right? It's a multi-mode fiber. For single mode fiber, because it only allows one kind of light to travel through the cable, so this kind of fiber is more suitable for long distance transmission and also with high cost. So just know the difference and remember the difference. Right? Here is a typical use fiber and a connector. Right. So for this part, just for your information, no SUCNE will examine this part. So just for you to get familiar with this kind of a physical connector, right? So you may already see that in your daily work if you already get into the customer's machine room or something like that. And along with the development of Ethernet, we already have the fast Ethernet and the gigabit Ethernet. This is a little bit back of time a little bit, right? Because right now we already have 10 giga, 40 giga, and 100 giga. So the information on this page are a little bit out of date. And here on this page is important. So because this page explain how Ethernet switch or where Ethernet switch works. This is for your information. For Ethernet switches is the devices working on layer 2. working on layer 1 and both layer 1 and layer 2. And switches are the devices off data link layer because it can deal with the information of data link layer, right? And also for switches port could separate collision domain naturally, isolate collision domain naturally for switch. For example, this device is hub. So all the port of this hub is belong to one collision domain. But this one is a switch. Switch is a device of data link layer, right? It transmit frame according to data link layer information. So the switch could separate or isolate collision domain naturally, right? Also, you can extend the physical transmission distance. You can do the job of a hub. You can extend the range, but also can separate or isolate the collision domain. So this is the difference between switch and hub. Physical layer device, data link layer device, right? Here, let's take a little question. Same picture, I just captured the picture from the PowerPoint. So could you tell me how many collision domain in the PIC? According to the information I shared just now?
4.
It's 4. Any other answers? Because I said for switch is the data link layer device, and its port could isolate collision domain naturally, but hub could not. So along with this hint, where can you go with this hint? Any other question than 4? 4 directly speaking, the 4 is not correct. I wait for 1 more minute. Anybody else?
It's 7.
It's 7. Perfectly. It's so could you tell me your answer is correct, and could you tell me your idea? How you got 7? Hello? Could you tell me why you got 7?
Basically, they. Can you hear me?
Sir?
Can you hear me?
Yes. Perfectly.
Basically, switch every single port of the switch is having a separate collision domain, and a hub is a complete entity of the single collision domain. And as compared to the switch, have switch has connected with the 5 system which are separately switch has connected with the 5 PCs, and connectivity between the switches and hub is a separate collision domain, and every system connected with the switch is a separate collision domain. So as calculating all the system and the connected ports are like
Okay, that's a perfect answer.
Check with the ISP. Just please provide the address where the part should be picked up.
The summary is, in order to find the collision, all the job we need to do The only job you need to do
You need to
is
pick
find
up the part
how
and
many
hand over the
ports
faulty one.
on a switch in this picture. For example, when we see this question, we firstly, could you help me mute your mic? Hello? Could you help me mute your mic? Thank you. Okay, so when we see this question, we firstly distinguish, or we want us to find the collision domain, not broadcast. So for collision domain, the purpose.
मैं वही कह रहा हूँ, अपना एड्रेस शेयर कर देता हूँ और इसके नीचे ये वाली लाइन दोबारा लिख देता हूँ। ये वाली लाइन सर, मेक श्योर सर।
贝志能帮我静音吗？
什么？
能帮我把它静音吗？
好的。
Sorry, will you mute your mic for a second?
हाँ सर।
Okay, let's move on. Time is pressing, so let's move on. So when we find a collision domain, so the target job for us is only to calculate how many ports the switch has, right? For example, this is a hub. Hub is a physical layer device, so we don't need to take a look at it. We don't even have to look at it, right? We just skip all the hubs and find a switch or two switch, and then the next job is to calculate the ports. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, 6, 7. So the final answer is 7, right? All the ports, how many ports on switch defines how many collision domain. But one further step, if this question is talking about broadcast domain, so switch port will not be useful. We will calculate routers port. So that will be the information for the next chapters, right? So just for your information.